Okay, here we've got the vectors question. We're starting with 2 points with known coordinates. So effectively we've been given the vectors OA and OB, though really you'd have to write these as column vectors for that to be strictly correct. To get the vector AB, nice easy starter for 2 marks, you have to subtract these two vectors the correct way round. Then for cos theta, well, you should know a method using the scalar product for working out angle between two vectors. That's in your notes. We've just got to select the right two vectors to feed into that recipe. The angle we want is the angle OBA, and in these situations always draw a diagram with points O and A and B, and OBA means the angle formed as you go from O to B to A, in other words the angle at B. And so these are the two vectors you need to set up and use the scalar product of in order to get this. So although they've made you get the vector AB, notice it's the opposite of that you need to work with from the diagram. Then in part B, we're told that a point C has OC equals twice OB. Well, that was effectively the vector OB, so this is just telling us the coordinates of C. So the coordinates of the point C, or the position vector OC, are straightforward to get if you keep your head. And then the line L is parallel to AB, so we're given a direction of the line, and it goes through the point C, so this point here that you've been able to calculate by doubling OB is the position, and you just need to feed the direction and the position into the standard recipe. R, or XYZ, equals something plus t times something else, or you can use a lambda or your favourite letter for the parameter. Put the position and direction in the correct way round in these two positions, and then you'll have got those 2 marks. And then finally, one that takes a little bit of thought, we've got D, which is on the line L, so D is on this line, and the angle ODC has to be 90 degrees, in other words it's perpendicular, and the test for perpendicular vectors is that the scalar product, the dot product, is 0. So we're going to be doing a vector dotted with another vector and getting an answer of 0. And of course we've got to get the correct two vectors. So ODC, well, once again we're talking about a point O, a point C, and a point D, but the right angle's at D, so ODC is a right angle. So the two directions are OD, or if you prefer DO, and the line, the direction of the line through C and D. But the line that goes through C and that D also lies on is this one here. So for the direction through D and C, this is simply the direction vector of the line. So the other one we need is the vector DO or OD. It doesn't actually matter which way round you have that, because either way it's perpendicular. Both of these angles are right angles. So OD is the vector we need to set up, and all we know about D at the moment is it lies on L. In other words, it's generated from this equation. So therefore, this side of the equation, these two vectors combined, which you can do as a single column vector with some numbers, and then some numbers times t in the second bit, you can get a vector involving t, which will be the vector OD, which you can dot with the direction vector of the line set to equal 0, which will give you an equation involving numbers and t's equaling 0, from which you'll be able to get a value for t. And once you know, not 0, won't be 0, once you know a value for t, you can just plug it back into this expression for your vector OD, and lo and behold, you've got the coordinates of D.